Yeah, okay, we'll just go rip through this intro thing, and we'll do this for all classes since we probably have new people here. The one lesson that I learned from last time, so anybody that is here, if you have a question, what I need you to do is I need you to raise your hand in the app, in the app. Last class, I literally had people raising their hands. Again, we got anywhere between 20 to 50 people. I literally cannot see you. Don't don't do this. Go to the computer, click raise hand button in computer if you have a question, because then I've got a screen and I can see what the hell's going on. Generally, these classes we're going to do the seminar to begin with. The seminar will be about half an hour, 40 minutes, hopefully. Appreciate generally to wait till questions at the end, till the end, unless I ask you if you have any particular question, just make life easier. So we'll do the talk. We'll do the seminar to begin with, and then we have labs at the end. Again, here's the thing. If you want to be a coder, if you want to be a professional, you have to do the labs. If you are not actually coding, if you're not tippy-tap typing coding, you're not doing anything. Again, this is interesting. Literally, if you do not do any coding at the end of this, this is about as valuable as watching Tim Pool. Right? Like there's this weird thing. People think they can just listen and they're going to learn code. That's just not really how it works. Anyway, Silicon Dojo, authorityless, gatekeeperless, free to end user, hands-on technology education that empowers students to do whatever the hell it is that you think is important. Again, these are very valuable things for me. Well, those are very valuable. We'll see if it remains to be free. Authorityless, gatekeeperless, the idea is anybody should be able to sign up and should be able to get education without there being any barriers that don't necessarily need to be there. Free to the end user. I would like to continue to make this free. We'll see how well that works. Hands-on tech education. Again, you need to actually do the work. If you're not doing the labs at the end of this, man. Anyways, and then empower students to do whatever the hell it is that you think is important. I do want you to understand about this. Whenever you're doing these classes, this is not about a certification. This is not about a degree. I don't care what you do with this at the end of the day. If you create the next Facebook or you just build a website, any of those things is fine. But I really do want you to be thinking about what are you going to be doing with this technology to actually do something that makes your life better, right? Really be thinking about that with all of this. No tests. Everyone is welcome. Your takeaways are your business. Copyright, again, with a product. One of the products that I'm giving you is this actual class itself. The other thing is that I'm actually trying to create this system. That's why we have the GitHub account. Basically, more or less, unless I state otherwise, everything on that GitHub account is yours for the taking. Not only can you use it to learn on your own, but if you actually want to take that material and teach people in your own environment, that's part of what I'm trying to do here. Donor box, again, free to the end user, isn't actually free. I do need to get paid. I mean, these screens, they still do cost a couple of dollars. You don't actually get them out of Cracker Jack boxes anymore. We have a donor box account, donorbox.org/ETCG. I'm going to have that link more often. If you'd like to throw some money in there, that would be ever so lovely. Tippy tap or die, professionally speaking. If you don't actually do the code, I don't know, you're not learning how to code. Extra help. If you need things, w3schools.com is absolutely fabulous for if you need additional things, again, with lists. Basically, like anything in programming languages, you just need a basic, explanation of what you're trying to do. W3 Schools is amazing. Whether it's Python, whether it's CSS, whether it's HTML, whether it's JavaScript, most of the programming languages you're going to be dealing with, W3 Schools is just a phenomenal resource if you haven't been there. And then ChatGPT. ChatGPT is not intelligence, is not AI, but is really good with explaining code to you. So use ChatGPT if you get lost. Form honesty, whatever, and standardization. Just so you know, we use VS Code, hopefully with default settings. Standardization is very important. I'm going to try to help troubleshoot you. So when you're doing the labs, you can raise your hand in Zoom. We can actually do a screen share. I can pull it up on the screen and I can try to explain to you what you're doing wrong. The important thing there is you can use many different IDEs in order to write Python. You can use a text editor, God help you, to write Python. But if you do, it is going to be much harder for me to figure out what's going on. Because again, when I pull up VS Code, everything looks like this. So if it doesn't look like this, I go, oh, and that's blue instead of red, or that's white instead of red. It's very easy for me to help troubleshoot. If you're using PyCharm or Notepad++, right? I look at it, I'm like, crap. Quotation mark, quotation mark, quotation mark, quotation mark. I'll still try, but it's gonna be miserable for all of us. Anyhow, there we go. Those are the basics. So let's get into the class today. So that's you guys. Yeah, so this is the GitHub account. It was in chat. So basically it's github.com, Silicon Dojo, online classes. From there, you can grab the information that you need. And with that, let me do something here. Let me move this over here so it's easier to find. Okay, so lists and dictionaries. Incredibly unexciting stuff that is incredibly important for you if you're going to be dealing with Python. So one of the big things you have to be thinking about with any programming language that you're going to be learning is what the hell do you plan to do with it at the end of the day? Right? So again, C Sharp. If you're going to learn C Sharp, that's all about the Microsoft stack. If you're going to be connecting to Azure and Exchange servers and whatever the hell Active Directory, whatever hell Microsoft has going on right now, Azure, C Sharp is the way to go, and there's ways to do things there. Again, JavaScript does its own thing, CSS, HTML, Ruby on Rails, all these different programming languages. Basically, they are valuable for whatever reason that they're valuable for. One of the big things to be thinking about with Python is one of the real values of Python is the ability to parse information and then pull out value from the information that's been gathered and then do something with that information. Again, store it into a database, send an email, create an automatic report, all of those different types of things. Well, basically what we're talking about when we're talking about parsing is when your script or when your programming language literally reads a file, generally it's a file, and basically looking for certain information so that you can pull that information out. The big thing to be thinking about in the programming world, though, is nothing auto-magically happens, right? Again, as a technology professional, and when I'm sitting there and I'm talking to a CEO, I will say, and then things auto-magically happen. I have zero interest in explaining to my CEO how parsing works. Balls to that. I don't have enough time. Here's the thing. You guys are tech professionals, so you don't get to say it auto-magically, right? So literally, everything you're going to do in that program, you literally have to design and you have to write for the thing to do whatever the hell it's supposed to do. And so when we talk about something like parsing, that sounds pretty simple. I'm going to have my Python script parse a document. Great. What does that actually mean? And so the thing is, with lists and dictionaries, basically these are ways to basically pull apart things like basically data, documents, that type of thing, to pull out information that is valuable. Again, test against that information, I guess, to determine whether it's valuable, and then do something based off of that. So something like CSV files. So a CSV file is this. Right. So again, when we talk about data stores, right, a lot of times we think about things like databases, MySQL, MariaDB, MongoDB, SQLite, those kinds of things. One of the things you can use as a data store is something called a CSV file. So comma separated value file. And so what a comma separated value file is essentially, think of this as a really damn ugly Excel spreadsheet, where essentially every record is separated by a new line character. So this is a record, this is a record, this is a record, this is a record. And then every value in that record is separated by a comma. So first name, comma, last name, comma, age, comma, email, comma, female, comma, extra small, so on and so forth. So although it's all over the place here, as far as the computer is concerned, right, this is a record for Joseph Bowen. Joseph Bowen's age is 47. Angela Zimmerman's age is 29. Kyle Stone, email address is this, right? And so basically what we can do is we can use a Python to come through here and parse this information to pull out or deal with this file the way that we want it to. So imagine we have a CSV file like this and we want to send out a mass email. So we can use an API, basically something like SendGrid, which is basically an email service we can interact with programmatically. And what we can do is we can simply come through here, we can pull out all of the email addresses using Python. And then basically for each one of those email addresses, we can then send the email for whatever notification it is that we want to send, right? And so basically, like with this, if we're parsing through this, this will get complicated, but basically like with this, so there would be a list. So every record would be an item in a list. And then that record would actually get separated into its own list within that list. It's a nested list. We'll talk about it in a minute. Anyways. And so that's one of the important things, like with lists and dictionaries, is that it's dirt boring until you actually start needing to do something with it. Let's see here. So arrays and Python. Again, the big thing to remember with Python is arrays are not just simply built into Python. Again, we've talked about that with modules before. Almost everything that you want to do in Python, you need a module for. If you want a random number, you need to import a module. If you want to delay the script code for 2 seconds, you need to import a module. Damn near everything in Python you need to import a module. So arrays, you can have arrays in Python, but you have to import an array module, or there's some other modules out there you can import in order to get access to arrays. They're not there by default. Now, right now, as I'm saying this, it probably isn't going to seem to be that big of a deal until we get to some of the math issues later. You don't realize how you like math functionality until the math functionality no longer exists. But anyways, so arrays are not accessible by default in Python, though they can get there if you want it. Modules can be used for arrays. Sets. So again, we talk about these when we're talking about a list. We talk about a dictionary. We talk about a tuple. We talk about a set. There's query sets. There's a whole bunch of other different types of sets in Python. Basically, what these are variables that have multiple values in the variable. So generally, if you have an int variable is a whole number, 1, 10, 512. A float is a decimal point number, 1.10, 1.2555555, 1,000.66666, whatever, right? That's a float. A string is a whole bunch of words, hello world, that type of thing. And we're talking about sets. Basically what sets are is they're one variable, and they have an index. And at each one of those indexes, you have a value. And so that you can pull out information or interact with those individual indexes. Let's see, if you're used to arrays, then basically a list is like a number indexed array, right? Array at index 0 has this value. Array at index 25 has this value. That's just a numbered array. Dictionaries are like named key arrays. So a named key is if that index actually had a name to it. So I want the name of this person. Let's say I have a record for a person. I want to get basically dictionary name, and that would give me Bob. Dictionary age would give me 55. Dictionary gender would give me male, right? So basically it's a named key array, if you know what the hell I'm talking about there. When you're using things like lists, getting even basic math functions like average require a bit of code. So this had me confused, like a year and a half ago. Because again, sometimes you just need to average, right? So you got a list of numbers. You got a nice list of ints or floats. And I just want to know what the average out of it, right? I got 10 numbers, just give me the average, right? So again, a lot of arrays, there's some code, you just say, hey, what is the average? And it gives you the average. It's not how it works in Python. In order to get the average, I crap you not. You have to add up all the values. Basically, you have to do something called a for loop, where you pull out all of the values in that list, You add them all together. You then divide them by how many indexes are in the list, right? Basic math, that gives you the average. So in most programming languages, you simply do something like AVG, whatever the array is, and you get the average. In Python, you write like 5 lines of code to get the average. So yeah, the first time I saw that, I was like, yeah, that's stupid. There's no way in hell that's how you actually do it in Python. And that's how you actually do it in Python. So anyways, as long as you understand that, you'll be fine. Importance of data formatting. So this is going to be one of the big things. Again, especially with new people, right? New people just want to get right to the code. Eli, I don't want to care about CSV files or anything like that. I just want to get right into coding. That's the real work that we're going to be doing. It's very important to understand the real world of being a technology professional. It's the planning, the documentation. Again, that's the kind of stuff that actually gets us paid. And so one of the big things to be thinking about is with your system or systems that you're going to be pulling from, how are you going to be formatting the data? Oops. All right, so again, with this, right, so I pull 50 records. This is actually 50 records. And so this is all pre-formatted. So even though I don't have a lot of information around this, I know where everything is, right? I know at index 0 should be the first name. I know that index 1 should be the last name. Index 2 should be the age. Index 3 is the email address. Index 4 is the gender. And index 5 is the shirt size, right? So I know that for this record, and I know it for all of the records, right? So if I'm going to be dealing with a CSV file, it's not simply important that I can turn this CSV file into data that I can interact with, but my code is also going to need to know where does email address, right? So email address is at 0, 1, 2, 3. Index 3 is going to give me the email address. Think about if I had this data. An email address in this record was here, an email address in this record was here, an email address in this record was here, right? Now, at the end of the day, you can still parse that crap. It's gonna make your life a lot harder though, right? And so one of the things that you need to be thinking about is basically how are you going to be formatting your data, again, for databases, for CSV files. When we talk about the data store, when things go into that data store, how are we going to be formatting it so everybody knows how to interact with these files and it's not a cluster F. Right. So if you're dealing with relational databases, there's something called the schema. So again, the schema is basically when you have a table, basically the column names in that table. Again, name, age, email address. So when you're building tables in a relational database, you have to design the tables before you start putting any data in. And so you want to spend a lot of time figuring out what the schema of your database looks like before you input even the first record. So it's one of those things to be considering. And again, like once you start parsing files, there's something called XML, Extensible Markup Language. You may see this in RSS feeds. You see this sometimes. And basically with XML, it looks like HTML tags, but basically you can use tags to basically state what data is. Right, you can do a title. So open title tag, close title tag, anything in between is the title for this article. URL for this article, open URL tag, close URL tag, right? And that's by putting those XML tags in, it allows your programming language, it allows you to basically design your programming language so it understands how to read those files, things to be thinking about. Again, and you have like things like CSV files, comma separated value files. And so that's one of the things you're going to have to be considering and what you should start looking at. Again, when you start looking at files or data and thinking about how you're going to parse it, start looking at how those files are designed so you can start trying to figure out, oh, if I can chop it into parts based off of whatever. Okay, then I think I can get my script to be able to read through it a little bit better. Let's see here. So lists. When we talk about lists, basically we create a list. So my underscore list. So when we do variables, again, we do not do camel case. We do underscore, my underscore list. If we're doing numbers, It is simply square. So square bracket for a list, 8, comma 9, comma 77, comma 3, comma 2, comma 10.22. You can put floats in there. Probably should put a float in there. Anyways, basically, if you're creating a list and all it is numbers, so ints or floats in the Python world, you just put them in there and you separate them by commas. If you're doing a list and it has names in it or strings, right? Basically, you create the list the same way. You have the square brackets, but then all the text in those strings has to be within either single or double quotation marks. So single quotation mark Bob, close, comma, open, Tim, close, comma, open, Sue, close, blah, 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 right? And then you can have a list that has different data types in there. And then basically you deal with those based off the particular data type. So Bob, so the name is within single quotation marks. The age has no, because that's an int. Large for the t-shirt size is single quotation marks. And then Boolean is either on or off, 0 or 1. So here we just put in true and see, so it's true. And this is the thing to think about. This is why you got to tippy-tap type this crap out. So true in Boolean is there is no quotation marks around it because it's not a string, it's a true. Right? True within quotation marks would be the string of true. It would be the word true. True without quotation marks is true. Anyways, in order to get access to one of the indexes, so you can do print my underscore list and then the index. So index 0 would be Bob. So here it would be 8. This would be Bob, and this would be Bob. When we're talking about indexes, this is one of the weird things with the computer world, is in arrays and lists, basically the numbering starts at 0. Does not start at 1, starts at 0. So 8 is at index 0, Bob is at index 0, Bob is at index 0. 9 is at index 1, Tim is at index 1, 22 is at index 1. 77 is at 3, no. 2, I'm sorry, 77 is at 2, Sue is at 2, large is at 2, so on and so forth. We go over, take a look at listpy. Okay. Yep. So basically, this has, again, everything written out. So this is how it would look in VS Code. And again, it's my say for troubleshooting procedures. It makes life pretty easy to understand how things are. So again, my list has some numbers in it. My name, it's a list that has names in it. My item is a list that has different items in it. Name, age, shirt size, true for Boolean. I can print out my list. So when I print out my list, it's going to print out everything. If I want to print out a particular index, a value-added index, I do print my underscore list, square brackets, 0, close square brackets. And then down here, we have an F string. So F string is where we concatenate. We add our own text, plus we add the values of variables, right, together to print something out. So we do F, hello, the value of at my item at index 0. So we'll say, hello, Bob, I see you're 19 years old, right? And again, this is where we start to see the power of dynamic stuff in Python. You'll also see here, this is where we use an escape. And again, this is the other reason why you guys need to tippy-tap type out, because this is the kind of stuff that'll screw you up. Remember, whenever we do a string, you're going to open with a single or double quotation mark, and you're going to close with a single or double quotation mark. Here's a problem. What if you have punctuation in between? So if I open with a single quotation mark and I close at a single quotation mark, then basically what's going to happen is it's just going to run to here, and then everything's going to go to hell. It's going to fail. So we use an escape. So using the backslash here, we backslash out, we escape this. So basically Python ignores this as actually a character for it to deal with, and that will simply get printed out on the screen. We go and we actually go run this then. We can take a look. Okay. And so basically we print my list. So 0, 4, 77, 10, 7. So if you just print out the list as it is, you'll just get the square brackets and the values. Again, sometimes you need to do that. Basically, it's like a var dump. What the hell am I dealing with? You just print it out. If I want to print out at index 0, right, I just simply do my list at index 0. That prints out 20. And then again, like I say, for this string, this F string here, so hello, Bob, I see you're 19 years old. And so that's how we are able to dynamically write something out to the screen. And again, when we're writing out to the screen, what you'll learn in next class on Friday is you can actually write out the documents. So this is a way that you could dynamically create a web page where you go to a web page, it pulls this information from somewhere, and instead of writing out in ASCII text, it could be writing this out in HTML, right? That type of thing. Okay, so that's a list. We have list functions. So there are some functions. So basically a function, so in the Python world, there are functions and there are methods. A method like tweaks a variable value. So upper is a method. So if you have a variable value and you want it to be all uppercase, you put it through the upper method and it'll be all uppercase. Lower is all lowercase. Title, right? That kind of thing. Anything else, if you're going to be like doing something that almost seems like programming, like basically what functions are. Functions in the programming world are kind of like tiny programs within your larger program. So if you want to send an email, you might send the email using some type of mail function. So here's a person's name, here's their email address, here's the subject, here's the text. You take that, you send that to a mail function, and that mail function does all the automagical stuff to actually get an email sent off to somebody. All right, and so basically when we're dealing with functions, with lists, we got a couple of functions. Got a couple, not many. You're like, what? But what else can you do? Not much more, much more. So you can pull the max value. You can pull the max value out of a list. So if you need to know what the max is, you can pull the min value out of the list, or you can pull out the length of the list. This is actually going to be the thing that's probably going to be the most valuable for you at the end of the day. So len, whatever the list is, that will tell you how many values are in that particular list. Is it 5? Is it 505? Again, especially once you start getting really large lists, that can be very valuable. It's not an array. You have no average or real math functions. Even to do an average, you have to do this stupid ass for loop that'll show you. So list functions. So basically, if we take a look at this, again, we have my list, 347, 1, 33, 555, whatever. I can print out the maximum value from my list, and it'll find the maximum value in here and give it to me. I can print out the minimum value from this list, and it'll give it to me. I can ask what the length of the list is. So 1, 2, 3, 4, 5, 6, 7, right? So you got 7 values within that list. So that's what we have there. So that's pretty simple. But again, if you want to get an average, you gotta do this mess. And this isn't a joke, right? So you have total equals 0. And again, we'll go into for loops in a bit. So 4x in my list. So when we talk about 4x in my list, so for each index in my list, total is going to equal total plus that value. So total equals 0 plus 3. And then we're going to loop. And total now is 3. So 3 plus 4 is 7. 7 plus 7 is 14. Anyways, you get the point. Once it loops, once it goes through all of these values in your list, then you have this value for total. So average equals total, so that total value divided by the length, how many values are in the list, right? Very basic math here. And then you can print out your average. And so if you're looking at this saying, God help me, there's got to be a better way, not if you're using a list. This is the Python way for certain things. So yeah, basically that's what we got there for the functions. You then have methods. So basically with the list method, again, a method in the Python world is anytime you can actually tweak the value itself. So we can sort. So if we have those indexed items, we can put them into either alphabetical or numerical order. Again, you can do this with lists. You can't do that with tuples, because tuples, you don't want to screw on with your x, y values. So you can sort, so alphabetical order. You can do reverse is reverse alphabetical order. You can do append. So append adds to your list. So let's say you want a list of email addresses. So you're going to be parsing a document file. Every time you find an email address in that document file, you're going to add it to your Python list. And then once you have that big ass Python list, you're then going to use that Python list and a mail function to send emails out to all of those email addresses that you found. That's what append does. Pop basically pops the value. So if you have a specific value that you want to pull out of the email address list, that'll do that. And fuck, what does remove do? You ever had one of those days? You're like, then there's remove. I'm having a brain fart. Anyways, let's go over to list methods. Go over to list methods here. Oh, remove. I'm sorry. Pop. Pop is if you remove at the index. Remove is remove a particular value. So anyways, so my list here. So my list, Tommy, Bob, Sue, Tim, and Patty. My list dot sort. So this is going to sort this alphabetically. Now, one of the things you're going to notice with this is a lot of times when you use methods for other variable types, so if you're using strings and you use upper or lower, you have to actually assign the value of the variable to the variable dot whatever method you're going to use, right? So if you're going to do like upper, so let's say string equals string dot upper, right? So it's going to give me an error. So if I had a string and wanted everything in the string to be uppercase, basically in order to assign that uppercase value to string, I'd have to do this. So I want string to equal the original value of string, but all in uppercase, and I'm going to assign that value to string, right? When you're dealing with lists, that's not how it works. If I do my list dot sort, so there's no equals anywhere here, it's literally just going to resort the list and it's done. You don't have to do any equals. And then I can simply print out my list as it is. My list dot reverse, we'll put it in a reverse alphabetical order. We're going to print it out. My list append to Timmy, so we don't have Timmy in here. So that's going to add. We're going to print that out. My list pop, so we're going to pop at index 1, 0, 1. So we're going to remove Bob. Then we're going to print that out. And then my list dot remove Patty. This is actually going to go to the value of Patty. And then we're going to print that out. And if we just go through here, so here is the sorted list: Bob, Patty, Sue, Tim, Tommy. Reverse: Tom, Tim, Sue, Patty, Bob. We added Timmy here. We popped out Bob here. Popped out whatever index 1 here, and then we popped out Patty for this one. So anyways, so that basically gives you that example. Ever have one of those days? Anyways, okay, so let's see here. Dictionaries then. We start dealing with dictionaries. Basically, dictionaries is where we have the named key. So you do my dict equals squiggly bracket. So this is squiggly bracket. It's not going to be square bracket. Then we have the key name. So name is within single or double quotation marks. Colon. So colon is what separates the values. So basically, the colon is the equal. Then Bob for the name, single quotation marks, comma, age within single quotation marks, colon 19. Since it's a number, you don't need the quotation marks. Size large, disclaimer, Boolean for true. If I want to get the name out of this dictionary, I simply do my dict. I call the key value that I'm looking for, and it should print out Bob. We take a look at dict.py. Basically, we can see this here. So my dict, again, name Bob, age 19, size large, disclaimer true. I can print out my dict, and it'll just print all that out. I can print out my dict name, and that will simply print out Bob. And then if I do the F string, like we did before, just so you know, for any new coders out there, this is what's called word wrap. Don't get worried about this. So what word wrap is, you can turn this on with a VS Code, is if your line gets the end of the screen and just wraps around to the other side. So especially with Python, whoo, things you forget to teach your students. I had a lot of students get very confused because they would see my word wrap and then they would format their text specifically based off of my word wrap, and everything would go to hell. So this is just word wrap, just so you know. And so basically we have here, print F, hello, squiggly bracket, my dict name, hello Bob. We have placed your order for a my dict size, large shirt, right? Again, dynamically doing this. And so again, so this is where we print out the entire dictionary. This is where we print out the single value we're looking for. And then we have hello Bob, we have placed your order for a large shirt. That's how you can dynamically basically create some kind of text. Let's see here. We go down to dictionary methods. So again, dictionaries have methods, a lot like lists. They have their own. We can pull out the keys. So the keys are things like name, age, disclaimer. We can pull out the values. So we can simply pull out the values. There's a method for items. We'll use this in the for loop where we can pull out the key and the value and then do something based off of that. We can update. So basically this is where we add additional information to a dictionary. And again, we can pop, we can remove information from a dictionary. If we take a look at dict function, so we have the same dictionary like we had before. So we can do print my dict keys. So we do my keys. This is simply going to print out name, age, size, and disclaimer. And so this kind of thing is really important. It's not as generally important as actually writing functional code, the code that you're actually going to push out to production. This is the kind of thing that's going to be very valuable for you to be troubleshooting. Because remember, a lot of times when you're dealing with code, right, you're not dealing with new code that you created. A lot of times you're coming into a legacy environment and you're trying to figure out what the hell data is getting sent to you. And again, if you don't name things properly, right? Then when you run your code isn't going to work. So a lot of times you have to pull out information just to figure out what it is that you're going to be calling. So by doing my dict print my dict keys, you can see all the keys that are being used, and then you can write your code based off of what the actual name the key is. Again, is it size or is it t-shirt size? Right? That type of thing. Values, it'll simply pull out the value. So Bob, 19, large and true. And then items, again, we'll pull out both. If we want to do my dict.update, so we can add allergy peanut. So we already have these values, and then we want to add that they're also allergic to peanuts. All right, print that out. And then you can do my dict pop. So with pop, again, let's say you no longer want the size. This is going to just pull out all the size. And then you're going to print that out. We go to run this. So we can see my dict keys, name, age, size, disclaimer. Dict values, Bob, 19, large and true. Dict items, so name is Bob, age is 19, size is large, disclaimer is true. I'll show you why that matters when we do the for loops. And then here, basically we added the allergy, right? So we did the update. So update allergy peanut. So now allergy peanut has been updated. And then we come down here and we pop out size. And so now size has been removed. So pop size, size goes away. And so these are the methods that you can use for dictionaries. Oh, let's see. We're clipping through pretty well. Jock, let me see. Ask to unmute. Jock, what's going on?
So you mentioned in the first class Python 2 and Python 3.
Yep.
Everything we're going over today about dictionaries and lists and how to kind of catch things if we're dealing with someone else's code. Can this be applied if someone put the code in Python 2 and we're doing it in Python 3? Or it's going to, none of this really matters because of the two? Can we use these same type of techniques to clean up code for that? I don't know if
Uh,
this really answers the question.
Basically, honestly, again, so Python 2 was supposed to die in 2020. So I started learning Python after 2020, and I had zero interest in learning obsolete code. So I got to imagine it looks a lot like this. I can't tell you what Python 2 actually looks like, though.
Thank you.
Yeah. Yeah, so basically what I was asking before is in our first class, I was talking about Python 2 and Python 3. So in many programming languages like PHP, like when I started programming PHP, it was PHP 4. They're now up to like 8.3 or something like that. And so with most programming languages, as they go, it's kind of like same, but different. The main functions are going to remain. Basically, functions that you probably weren't going to use anyway get deprecated. Deprecated means they basically get removed after a time, and then new functions come in. So, unless you're doing really complicated stuff, or if you're doing simple stuff, if you write PHP for PHP 8 and you put it onto a PHP 4 interpreter, it'll probably work. As long as you use the right functions, long as you used functions that existed back with PHP 4, it would function properly. If you create if you create code based off of PHP 4, it'll almost certainly work on a PHP 8 interpreter. Right, they're more or less pretty relatively cross-compatible. Again, be careful with that, but relatively. The thing is with Python is there was Python 1, God knows how long ago. Then there was Python 2. And basically, once they created Python 2, they realized there were problems. Like, it wasn't quite what they really wanted. And so that's when they came out with Python 3. And basically, Python 3 was a hard fork. It was a hard divide. So Python 2 code generally will not run on a Python 3 interpreter, and Python 3 code will generally not run on a Python 2 interpreter. And so basically, it's not like one of those, oh, you get a Python 2 book, it's good enough to learn the basics. No, it's not. And so you can run into a lot of problems. Again, the original end of life for Python 2 was supposed to be 2012. So again, we're talking about 12 years ago, it was supposed to die. Because of the bane of legacy systems, it didn't get to fact actually die until 2020. And that's also why I'm a little cavalier on it, is it's not simply, oh, it died in 2020 and I'm not willing to learn it. No. It was supposed to frickin' die in 2012. So, I figure once the technology is 12 years past when it was supposed to die, I'm not responsible for it. So yeah, if you need to learn Python 2, find somebody else because I truly do not care. Um, I guess we can do one more question. Cinnamon, how can I help you? Cinnamon? Yeah.
Hi, I'm super new to coding, but for the books and things that I've read, I haven't seen the F string before, and having a challenge figuring out why it's used and when it should be used.
Oh, so if you go to the main channel, the Eli the Computer Guy YouTube channel, so we did a class, oh, it hasn't been long ago. What, Monday, right? Monday? We talked about variables and F strings and all that. But basically, just for anybody, where the hell are my F strings? Give me an F string. That's not my F string. Dictionary? Okay, so this is an F string. So there's something called concatenation. And so what concatenation is, whatever language you're using is very important, where basically you write standard text, right? So again, imagine a web page that you're going to, an email that you're going to be sending, whatever, right? You want it formatted in a certain way. So you want to say hello, person's name, whatever, right? So basically, what concatenation is where you take the text that you want written out, and then you add the values of the variables. So I want to statically have hello, but dynamically plug in whoever's name it is that we're talking about. Then statically have this, and then dynamically plug in whatever the size of the t-shirt that they ordered, right? And so basically what concatenation allows you to do is it allows you to create this dynamic text where you have static text mixed with variable values, and that's the output that ends up going out to the end user. So in Python, there's three ways to do concatenation. There's pluses, there's commas, and then there's F strings. Not going to get into the pluses and the commas because unfortunately it gets a little bit complicated. There's this whole anyways, right? Those are the two ways. F strings in Python came out a few years ago, at least a few years ago. It's like we're in Python 3.12.4. It was something like F strings came out in 3.6. So it should be, right. Anyways, basically what the F string allows you to do, instead of the concatenations, the old, ugly, completely pain in the ass ways of doing it, with an F string, all you do is when you do print, right, or you do whatever, you simply say F to begin with, lowercase f, then you open your string as you normally would, and then simply you can plug in the variable names within squiggly brackets, and that tells Python to dump the variable value here as it's writing it out on the screen. So again, if we go here, okay, let's see, hello, Bob is a variable value. We have placed your order for a large shirt, right? So I go up here, right, and I change this to Sue. I can simply run this again. Hello, Sue. We have placed your order for a large shirt, right? And again, like all we're doing right now is we're printing this out to the screen. This is an output. But again, this output could be going to an email. This output could be going to an HTML document. This output could be going into a database. Right now, we're just printing this out on the screen. And so that's what the F strings or any concatenation allows you to do. That makes sense?
Yes, thank you.
Yep. Okay, so no more hands. Let's get through dictionary methods. Okay, so we have for loops. So basically, so we have these lists and we have the dictionaries. We have whatever sets. What for loops allows us to do is it allows us to step through these sets to do something. So we can do like a search. So let's say we're looking for specific names. We're looking for specific values. We can step through each one of the records to find a specific value. Or we can print it out on the screen, or again, we can send an email. So we would use like a for loop. So if I had a list of email addresses, I would use a for loop to grab an email address, send it to the email function. Grab the next email address, send it to the email function. Grab the next email address, right? Allows you to loop through. When you're dealing with dictionaries, it's slightly different. So we use that dot items method we talked about before. And so with this, we can say for key. So this will give us the key, right? So name, age, whatever. Value in my dictionary.items. And then as it goes through, we can grab the key and we can grab the value. We go and take a look at the for loop. For loop. Okay. Let me just do this real quick. So I commented these out, so you just look at one thing at a time, right? So my list, so we're gonna step through my list. My list equals Bob, Sue, Bobby, Bo, Tim, and Tommy, right? So for X in my list, so for each index in my list, I'm gonna print out X. So if we do this, we run this, we can simply see, for X in my list, it prints it out. So Bob, Sue, Bobby, Bo, Tim, and Tommy simply prints that out onto the screen. right? Pretty simple, just basically steps through. That's called the for loop. Let's see here. What we can do is if we're searching for particular values, we can do this. So when we say for x, right, we talk about a for loop. So a lot of times when we see these for loops, they just say for x. Basically, this is just the name that we're using for the value that comes out of the list. So for x in my list, if this is the name, the way that we grab it or whatever, we get the value is by calling it by that same name in the future. So for x in my list, print out the value of that name. So if we want to start getting to be more professional with our coding, we can start calling that value something that is actually relevant. So instead of for x, we can say for name. So now we're going to be calling this variable name. So name in my list, if Bob. So we did this before with if-else statements. So we can say if this string is in the name value, print that out. So let's say I'm only again, let's say I'm doing a search for something. So basically I'm looking for any names that might have Bob in it. So Bob and Bobby or whatever else. Basically you'd use this for things like email addresses, that type of thing. But anyways, if we print this out, what we can see is when it goes through and prints, right? Only Bob and Bobby have Bob in it, right? If I go here and I do Bo instead, and then I run it, I get Bob, Bobby, or Bo. And so this is just a very simple idea of basically how a search routine would work in Python. And so what this does is it steps through every value in the list. Basically, it does an if statement based off of the value that it's currently looking at. If the condition is true, so if Bo is in that value, then it does something. All we're doing here is printing something out. Okay, then we can come down here. And so we have the My Dictionary. Name is Bob, age is 19, gender is male, size is extra large. So here what we can do is for key, so the key is name, age, gender, or size, comma, value, value is the values, in mydict.items, so this method pulls out that key and value pair. And we're going to print out as an F string. I'm going to say, I want to know what the key value is, space hyphen, what the value is, and that will print that out on the screen. So if we do this, we can see the name hyphen Bob, age hyphen 19, gender hyphen male, size hyphen extra large. So that's how we can get that out, that type of thing. It is important to understand that we can use methods, text methods, or string methods, I'm sorry, string methods against this type of thing. And so basically all I've done here is we have the key, the value, mydict.items. We're doing the F string, but I do key.title. So the title method, right? The title method, what that does to a string value is it makes the first letter uppercase and everything else lowercase. Then hyphen, string. Basically we turn this value here into a string. So this is an interesting issue, right? So if you're going to be iterating through something like a dictionary, one of the issues that you're going to deal with is, again, that data type thing. So we talked about data types before. Int is a whole number, float is a decimal point number, string is text, right? Plus we got bool or whatever else. One of the things to be thinking about when you're looping through is, so here, I want to make all the values uppercase, right? So I want name, that to be title, and I want Bob, all uppercase. Gender, title, male, all uppercase. Size, what a title, extra large, all uppercase, right? So that seems pretty simple. Here's the thing. That's an int. That's an int. can you make an int uppercase? And the answer is no. You can make a string uppercase, but you can't make an int uppercase. And so if you have numbers that are of a string data type, you can tell them to be uppercase and nothing is going to happen. But the script is still going to run. If you have an int and you try to tell it to be uppercase, your script is not going to work because you can't make an int uppercase. And so here, since I have this one int value here, when I'm calling any of these values, I'm going to turn them into strings. So once they are a string, I will then make them uppercase, and that will make everything uppercase. And again, this is the kind of thing that's going to kill you with data types. Again, this is why you got to tippy-tap type crap out, because until you start doing this stuff in the real world, you're going to be like, but no, that sucks. It's like, yes, it does. So anyways, so we run this now. Basically, we can say name is title, Bob is uppercase. Age is 19. So this is a string data type. So we told it to be uppercase, but it's numbers, so it doesn't care. Gender is male. Size is extra large. That is all uppercase. Just to show you, if I took out this string thing, oh, so I did that, right? So value dot upper. So it would try to do Bob, that would work. But again, you can't do an upper for 19. If I try to run that, this is where we will get the error. Int object has no attribute upper, right? Because it's an int, you need it to be a string. And so that's the kind of wonky crap you've got to deal with in the real world. Again, that's where I say you don't have to be smart to be a programmer. You do have to be relatively precise. Relatively precise. Let's see here. Nested lists and dictionaries. So one of the fun things with lists and dictionaries is that you can have lists and dictionaries inside lists and dictionaries. And if this starts to melt your brain, it's okay. Oh, this is one of those things where you can theoretically you can tell everybody exactly what they need to do and their brain is still gonna melt. So basically, again, nested is where you put a list inside a list inside a list inside a list. To give you a hint how bad this can make people's brain melts, I actually had one of my viewers. I used to do meetups back in Baltimore. And I was talking with him, and he was a Python programmer back in the day. And he had a buddy of his, and the way that his buddy got job security is basically all the configurations that he did for the platform that he had designed for a company were 9-layered nested arrays. So you had an array in 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 an array. And though theoretically, you can just grab a whiteboard and try to figure out what's going on. There's something with human brains. Human brains just start melting after about the second layer in one of these nested things. So it's going to be one of those things that, yeah, if you get to this and you get a little bit frustrated, that's completely understandable. Well, welcome to be a technology professional. If you do run into problems with nested, right? Lists, dictionaries, arrays, sets, whatever. This is one of those places where ChatGPT can be absolutely awesome. You take your nested crap, you throw it into ChatGPT, and then you basically ask it, what index is this information at? And it will give you a nice response. That might be one of the things that you want to do with. If we go to nested.py and take a look at this. Oh, where is nested? Nested.py, there it is. So this is a very simple nested deal. So we have a list. So here we have a list of dictionaries, right? And again, this can get stupidly complicated. And so basically the idea with this is think about if these are records, right? Again, we talk about pulling information out of something like a CSV file. So we would have lists, or we'd have dictionaries within a list, right? And so we open with a square bracket. So a list, you call values in a list simply by their index. So this record is at index 0. This record is at index 1, record at index 2, 3, 4, and 5. So basically nested, you go to 0, and then inside of that, you then have a dictionary. And so then you call the value from that dictionary by that named key, right? So if I'm trying to figure out basically Tim's record here, I would use, so nested is the variable name. So I do nested, square bracket 2, 0, 1, 2. So this is the record. And then I want the name, the value of name is Tim. So that's how I would call this. If I wanted, let's say, Lori, I would go to nested 0, 1, 2, 3, 4, 5. And then I would go to name, and that would give me Lori. If I wanted Lori's age, I would go to 0, 1, 2, 3, 4, 5, age, and that would give me the age, right? So if I run this right now, right? So it gives me the name of Tim. If I go here, right? And so I do, again, I do 5, as I said before. It then now gives me the name of Lori. If I then go here and I simply say age, it will then give me the value of Lori's age. And so when you're doing the nested, this is where it starts to stop. And again, it's like, okay, so you go to that index, and then you go to that name, and then in here, there might be a thing. So let's say, oh, let's just say, I think this should work, list. And I don't know, list, and then I can do 3, 33, 88, 99. So then if I did list, and then God help me, hopefully this works, 1, that should give me 88, I think. Let me clear that out. Let me run this. There we go. That gives me 88, right? So I go to the 5th index, I go to the list name, I go to the second value, and yeah, just imagine if you had to do this for 9 levels. And then you would understand why that person had job security for a lifetime and was also a complete bastard of an employee. But anyways, so this is what nested arrays look like. We can answer a question. Jock, what's going on? Jock?
All right, thank you. So for the example you gave with that guy, and he had 9 layers deep of nested information.
Yep.
You're asked to find out a specific person. So you have 100 names between Tim, Patty, Lori, whatever, and
Yep.
you're trying to find an age. How do you find the age of a specific person if you don't know where it's nested in? How would you kind of like write that? So say, for instance, you had a Mark, age 20, but you don't know exactly where that name is listed. Because in your example, you have Lori as number 5, but you don't know at what point she's nested. So how would that look when you're writing that to find a specific name and a specific type, but you don't know exactly where it's listed, but you're trying to find it? If you can
So
understand my question.
yeah. So that's where, all right, so let's see if I can code on the fly. So we'd say for record and nested, and then we'd say if, let's say Patty in record, right? So this is the record, right? So Patty is in the record. Print, hopefully this works. F, record name. Oops, squiggly brackets. And then record age. God help me. And so do remember with concatenation, single quotation marks, double quotation marks. And if we run this, oops, okay, for record print, S, for record and nested, if Patty and record. Yeah. Hold on 1 second. Yeah, Patty is there. If Patty and that's a shit way of doing it. Yeah, there we go. Actually, the best way to do that with that one. Again, it's hard doing this stuff on the fly. And name. Okay, so for record and nested, right? So nested is this mess. Each one of these things is considered a record, so we'll just call it record. So for record, so we're going to go through each one of these records and nested. If Patty is in the record name, then we're going to print out the record name and her age. So if we do that, there we go. We get Patty, who is age 5. So that's how you would loop through to find specific values, and that's why there's something called primary keys, or there's keys that you normally use in databases. So whenever you're dealing with a database or whenever you're dealing with a data store, especially if you're going to be modifying things like records, you always need a unique key, an absolute unique key. So think about your social security number, think about your driver's license number, think about your passport number, or it can just be a record of auto increment of 0, 1 through whatever. And basically that is going to be like the unique key for whatever record you're dealing with. Because like with this, I pull this out and I get Patty and 5, right? So I'm looking for Patty and I get Patty at 5. One of the issues that you can run into is, again, imagine this was 5,000. Imagine this was 100,000 records. What are the chances you're going to have multiple Patties? You have 5 Patties. And what if when you're running this, you're not simply running it in order to pull out information? What if you're running it to modify the record? So you say, if Patty age equals 30, let's say. And then since you're not using a unique identifier, it's going to change the age to every Patty it finds to 30, which that gets the mess into the mess of real programming we're not dealing with today. But anyways, yes. So this is basically how you would loop through, and it's essentially the idea of how you search for records. And any kind of programming language, it's kind of same, but kind of sort of look like this. Does that make sense?
Yes, thank you very much. Didn't mean to put you on the spot.
Oh, yeah, no problem. Let's see, how many more we got? We only got 2 more. Jonathan, what's up?
Hi. About this, do you have to define the record? How is it for record in nested? Do you define it as a record or as a name or anything, or do you just call it?
I just call it a record. I could call it Bob. I could literally call it Bob.
And it would be for every element in nested, let's say, for key in nested or something like that.
Yeah, so basically this is just a name. So now that I've changed all of those, and it still comes out. Yeah, so there's no, again, this is where we talk about syntax versus style. So this is the syntax. how you name things is the style, right? And so that's where you want to name things as appropriately as possible. So when somebody reads your code after you, they know what the hell you're talking about.
Okay, so as long as it's consistent in the for, but it's not been defined.
Yeah, so basically this is where we're essentially creating that variable name here so that when we call, so we need to use that name when we call it in the future. But it doesn't really matter what that name, technically, it doesn't matter what that name is.
Okay, thank you.
Cool, cool. Okay, got a couple more slides and we'll get to the practicals. A while loop. So since we're already doing for loops, again, there's not a lot of loops in Python. Python's really interesting, like because when you start learning about Python, you're like, wow, it's the most advanced programming language out there, right? And we're gonna do classes on it, right? You can use Python to do artificial intelligence. You can do Python to do computer vision, computer speech, all this like mind-blowing crap. But then when it comes to things like loops and arrays, it doesn't have very many options. And so like there are do while loops. If you deal with other programming languages, there's a whole mess of different types of loops that are out there. Basically, more or less with Python, there are two. There are for loops and there are while loops. While loop, basically the code loops until a condition is met. You want to be careful that you do not create a permanent loop. So basically this is where your program will crash. Create a loop where a condition never can be met for some reason, then the loop will just continue forever. And basically, so while x, let's say, is less than 10, do something. So I talk about a while loop here. A loop. So this is a while loop. So again, this seems more complicated than a lot of other programming languages. Yep, it's just how Python is. Deal with it. So we're going to create the variable that we're going to be testing against for this while loop. So this is simply how you can iterate through something. So we're going to say x equals 1. So we create the variable of x, we assign the value, we set the variable to 1 as an int. So while x is less than or equal to 10. So this is important. Again, this is a conditional. So the conditional is you can either be equal is equal is equals to, and the data type is the same, less than, greater than, not equal to, or less than or equal to, or greater than or equal to. So while x is less than or equal to 10, we're going to print the value of x, and then we are going to increment here. So a lot of other programming languages, you'll see like x plus plus, or the variable name plus plus, or x, or the variable name minus minus. In Python, basically you can do this x plus equals 1. So x equals x plus 1. And that iterates up by 1. So it starts at 1, it'll print 1, it'll add 1 to 1, so that's 2, it'll print 2, adds 1, 3, so on and so forth. So we go, we run this. Basically very simple, prints 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? All the way down. Again, where you have to be careful, again, with these conditionals, is if you do x is less than 10, because that's what a lot of us think about. Oh, I want this loop to iterate for 10 times, so I want x to be less than 10. Again, where you have to be very careful with this is, basically since it's less than 10, it'll stop at 9 because 9 is less than 10. 9 is less than 10, 9.9999999 is less than 10, but you're never actually going to get to 10 because you want it to be that. Let's see here. Like where you have to be careful with this. Let's just say I did something stupid. So let's say I said 11, because again, like right now, I'm showing you very simple things. When you actually start writing code, this information is going to be coming in dynamically. It's going to be coming in from other sources in order to print out whatever. So let's say X was like 11 here. And then I did something stupid. Like I say, while X does not equal 10. All right, so X is 11, while X does not equal 10, print X, and then iterate. Well, here's the thing. If we start at 11 and we keep adding to X, X will never equal 10. And so if we run this, this is the mess that you're going to get. Where basically it's just going to keep going and going and going and going, and the loop will never break because the condition will never be met. Again, why this becomes important. Right now, I've got this running on a pretty powerful Intel computer, and this is just going to keep ticking up forever and ever and ever. There's two reasons that this is going to be a problem. If you're using local resources, one of the things you have to realize is that you will never break out of this loop. And so if the program needs this loop to stop before it continues, then it'll never stop. And so your program will just lock up. The other problem you can run into is things like, I don't know if I consider this a memory leak, but you get what are called leaks in programming, where basically you have, you fire off events, you trigger an event to happen, but it never stops. And again, one of the things you have to think about is scale, at scale. So if I'm running this right now, right, I can run this right now and I can do 1,000 other things. But what if this keeps getting triggered? So what if every time a user comes to your application, you get this loop to start that never ends? So you get this running once, and then you get it running twice concurrently, and then you get running 100 times concurrently, then you get running 10,000 times concurrently. At what point does this become a disaster in resource utilization on your server? And this is where you can get into what I call soft errors. So a hard error is like what I've shown you before, where you put the wrong thing in, you have put it in the wrong data type, and it just fails out. You run the script, the damn thing fails, and then you scream, go grab a cup of coffee and figure out why it failed, right? That is actually good. I'm telling you, hard fails, I'm all about that. In the real world, the problem that you get into is soft fails, where it doesn't fail outright. It just starts acting quirky, as we call it. And it's like, well, it doesn't seem to be working how it's supposed to be working, but it kind of sort of is working. And then you get into this whole thing, like we'll start talking to like real tech professionals, and like a system will crash. And then like the first thing will be like, okay, well, how many times has it crashed? Oh, it's crashed 10 times. Okay. Does it crash the same time per day? Does it crash during when a certain event triggers? That type of thing, right? And so that's where you've got to be careful of these. Oops. Okay, finally locked up. Oh, shit. Oh, damn. Oh, God damn it. Okay, good. I thought I locked up my own computer. That would be bad during class. The other thing with this kind of conditional loop is especially when you're making API calls. So I've talked about this before, especially with OpenAI. So we're going to be doing classes with the OpenAI API. So that is basically the way you can interact with ChatGPT from Python. Anyways, whenever your code goes to talk to ChatGPT, it's going to cost you a fraction of a cent, somewhere between 1/5 of a penny to 1/10 of a penny. Who the hell cares? Right? You can put $1 into your account and you can use it for like the next year, right? In a non-production environment. What you do have to be careful about is if you have this while loop and this is making an API call. If it is costing you 1/10 of a penny every time it makes an API call, and this thing is literally hitting that API as fast as the processor allows it to, with no end, because the condition will never be true, that is how you can get a $10,000 API bill in the blink of an eye. So be very careful with loops. Very careful with loops. If we go back, and that's where we get to the while true loop. So we will use while true loops quite a bit in these classes. One of the reasons I like using while true loops is it allows us to create kind of an interactive environment, kind of sort of like what a user would be interacting with, and so you can play with your code a little bit easier. Basically, what a while true loop is while true. So while true is true, while the sky is blue and rain drops from the clouds and gravity exists, it'll always run, essentially. It goes on forever unless you specifically break it. If we go over, take a look at this while true here, for a loop here, again, x equals 1, while true, print x, right? If we do this, basically, again, it is while true, the condition it'll never break because it is while true, while truth exists, I guess. It will keep going. Why we use this, and again, it will only break if I do this, is why we do this is, let's see, message equals input, say something. So you've probably already seen this in projects we've done. So this is why I like using the while true loop. We can get rid of that x equals 1. So basically what I can do here is I can run this. It says say something. I can say hello, and then it simply prints out hello. Yo, right? And so why we do this in a lot of our projects is it allows us to create a kind of interactive environment for a user. So basically we can have you input a message, at the input prompt, and then we can process what you've said in order to have events happen. We can have if-else statements here, we can have conditionals or whatever else. And so this is one of the reasons that I kind of like using while true for these classes. But that's why we will use these here. But again, in the real world, be very careful, because if you start hitting APIs, it'll be a bad thing. Could be a bad thing. So that is the class. Then we've got some labs for you folks to do. Again, the entire point, if you're going to be learning how to program, is to tippy-tap type. You cannot learn how to program by simply sitting there. You do not learn how to program by reading. You do not learn how to program by listening to me. You learn programming by actually doing stuff. So we have these labs, lab-append, lab-search, lab-repayment. Again, on GitHub. So we have our GitHub account, github.com, Silicon Dojo, online classes. If we come here, we do the refresh. So we have this class for Python dict loops. We can come in here. The lab code is here. So we have lab code here. We have code examples here. And here is the lab book. So we have the PDFs. So we click on the lab book. So you can either print this out on a nice piece of paper, or if you have another computer screen, you can put this up on another computer screen. Do not copy and paste. You are not at the level of copy and paste. Someday you shall be a master, and then you can copy and paste. Today is not that day. If you're learning what a list is, you are not allowed to copy and paste. So anyways, we're going to have these labs. So append to a list. I'll show you this in a second. We're going to have like a minimum age lab, minimum age app, which will show you all the people that are above a certain age. And then we'll have a loan repayment calculator. If we go over, we take a look at these. So lab append. Where is lab append? Okay, so basically what we got with this is we create an empty list. So when we create a list, so we do my list equals square bracket, creates an empty list. While true, because you're going to be adding to this. New, so basically a new record, new value, equals the input function. And we're basically going to put out on the screen, add to list. And then we're going to say my list with the method append new. So every time this runs, you're going to add to your list whatever value you put in, and then we're going to print out. Pretty simple, just to kind of give you an idea of how this works. So, right, add to list. And when you do this, do make sure you put the cursor down here. Like, it's really easy to have the cursor up here and say, Bob. God damn it. Let's click down here, add to list, Bob, right? And then prints out the list Bob. And then we can say Tim. And it shows we've added to that list. And we can say Sue. And it added the list and Phil. Right. Anyways, right? So this kind of shows you how you can have this thing where you're adding to the list. Again, right now, this is volatile. Volatile, like as soon as I kill this, that value goes away. What you can be thinking about, though, again, this is where we start talking about data stores, where you could be creating this kind of list and then dumping this data into something, right? That's where it would have to get stored in the future. But anyways, that is the append. Then we have the search. And so basically with this, it allows you to search for students that are above or equal to a certain age. So again, we have dictionaries nested within a list. So we have Bob, who's 19. We have Sue, who's 21. Bill, who's 33. Bonnie, who's 9. Phil, who's 15. Right? We got these records. While true. So minimum age equals int input minimum age. So when we use the input function, even when we put a number in, even when we put 11 or 11.11 in, it is still going to come in as a data type of string. And you can't deal with number stuff with strings. So we're going to turn this into an int. So basically the input's going to come in as 11 or 30 or 55. We're going to turn that into an int. We're going to say print. This just prints out on the screen. These students can attend. For record in students. So for record in students. If record age is greater than or equal minimum age, we're going to print out the record name. That'll tell us who was able to come. So if we run this, and let's say we're going out drinking, we can put in 21 as the minimum age, and it will tell us these are the students that can attend: Sue, Bill, and Bobby. So Sue is at 21, she's at the right age. Bill is at 33, and Bobby is at 66. Maybe we want the kids to be able to drive, so we say minimum age of 16. Bob, Sue, Bill, and Bobby. Bob, Sue. Okay, so Bob is 19, so he's above the age of 16. And so that basically gives you, again, that idea of how you can search through these records to find a specific information. Past that, we then have the repayment lab. So it gets a little bit wonkier. So since we're dealing with dictionaries and lists today, again, do remember whenever you're programming, as long as it technically works, you can make it look almost however you want. So most of the time, if I was doing this, I would actually have these as different variable names. But since we've been dealing with dictionaries, might as well keep in the dictionary frame of mind. So we're going to create a dictionary called money, index of owed. We're going to start at 0.00, so it's a float. Monthly payment is going to be 0.00. So basically, this is going to be how much is initially owed. We're going to have a monthly payment, and it's going to tell us more or less about how long it's going to take us to pay off this particular loan. Years equals 0, so we're going to create the variable for years. This is what we're going to iterate against, right? We're going to initially set it to 0. So money owed, so money owed is going to equal input starting bill, so the original amount, and we're going to set that as a float. And again, this is where we're talking about ints and floats, and you got to be really careful. A float is a decimal point number, an int doesn't have a decimal point. The most important thing here is if you turn a float into an int, it takes the decimal point and everything past it off. So if we have something that's $11.25 and we turn that into an int, it will be $11. And that can cause a real big problem when you're dealing with math. So we're going to do a float. Money, monthly payment is going to be input, the monthly payment turned into a float. So while money owed is greater or equal to 0, so as long as you're above the amount that's still owed, print year, and then what year you're at. So we'll start at 0, equals, so this is actually equals, money owed, and so this will be the initial amount. So we're going to be at 0 with whatever the initial amount is. Money owed is going to equal money owed minus, this is where you got to start doing some math. And again, a lot of people ask with programming, they're like, Eli, do you have to be good with math And it's like, you don't have to know calculus or trigonometry, but you do have to understand how basic math works, right? So we're doing years, but we're talking about monthly payments. So within parentheses is just basic math here. So monthly payment times 12. So whatever monthly payment is times 12, that gets how much we're going to pay in a year. And we're going to subtract that from the money owed, right? And that is then going to be money owed. Years plus equals 1, right? So, let's say you owed $100,000. So we put in, start at $100,000, and you're going to pay back $1,000 a month. So it'll say year 0, money owed 100,000. Money owed will be monthly payment of 1,000 times 12. So it'll be 12,000 minus 100,000 means money owed will be 88,000. And so it'll then say year 1, money owed 88,000. Rinse, repeat, however many times it takes to iterate through. And then once it's done, it'll say bill will take however many years to pay off. This is not perfect math. You get to make it better if you want. So again, if we go and we actually run this code, we can say the starting bill is, let's say $100. Your monthly payment is going to be, let's say $2. And then it goes through. So year 0 is $100. Year 1 is $76 because 2 times 12 is 24. Year 2 is $52. Year 3, 28. Year 4, you still have $4. And so basically there's still $4 left. So kind of sort of take 5 years. Again, it's not the most precise math in the world. I'm not trying to teach you precise math. Basically just the idea of how these while loops work. And so those are the labs that we have today. So I am happy. Oh my golly, it's 3:30. I'm happy to hang around for about a half an hour more. And again, if you start tippy-tap typing and you run into problems, we can do screen share. And then with that screen share, I can try to walk you through what your problem is. And if there's any other questions, does anybody have questions about the class today, the labs, any of that type of thing? Yes, raise your hand in Zoom. Don't do this. This does not work. Let's see here. Alex is still unmuted. Anyways, Alex, yep.
Hello. I was just wondering if you could post a GitHub link in the chat.
Oh, sure. Yeah, I don't understand why chat like disappears after a little while. Come on, give me chat. Oop. There you go. It's in the chat now. Andy Fontaine. How can I help you?
Is there any place to find additional work to go through for the classes to be able to learn these things?
Any additional? Like I say, you can go through and you can play with W3 Schools, w3schools.com. Again, if you have not been here, any kind of these languages is great. You can go to Python, and basically it just has everything in the world here in a very simple explanation way, that type of deal. Yeah, that's basically that in ChatGPT. I mean, really, those are the best resources they have right now for learning Python at this basic level. I do want to start doing so with all this. Again, I've actually got to write all this crap. So we are in the future. Don't ask me when. We are going to have these classes where they will just be projects. So I'll actually try to design a more give you ideas of things that I think might be at your level and give you ideas of how you might try to work through that. So we'll try to do that in the future. But right now, basically, W3 Schools is the best I can give you for additional resources. Yep. Cool, cool. Chat doesn't disappear. However, people can only see chat history since they joined. Oh, okay. Computers. Computers. This is why I laugh at anybody who says they're passionate about computers. Well, okay, sure. Sure. Okay. Any other questions? Okay, if you're all typing away, any other questions in general then? I don't know. Beyond this particular class today. Before you started the lesson, what was the subject you were talking about? I don't know. It's kind of like my wife says that. I'll be like, do all these videos. She's like, Eli, yeah, so what were you talking about today? I don't, I don't know. I definitely talked about something. What was I talking about originally? I really can't tell you. If you can remind me, maybe I'll remember. I don't know what I was talking about. The RARs at the beginning. What was I talking about? Mm. Oh, oh, are you putting screen? Oh, golly. Why are we doing this? I love students. They always do whatever the hell they want to do. Are you putting Alex Smith? Okay, okay. Edward, I'll get to you in 1 second. We need to do screen share. So basically, if you need help with your code, raise your hand. Say, I need help with my code. Then I'll uncheck the screen share thing so you can share your screen, and then we'll take a look at it. That's how we will do it. Oh, Alex Smith, how can I help you?
Hello, I'm looking at the first lab append to a list.
Oops. Okay. Hello, can you hear me? Christ. Oh, Alex, there we go. Okay.
Okay. Yeah, my question was it, for the lab example lab append.py, how does the
Yep.
while loop ever end? It looks like it goes on infinitely. Is that attended?
Oh, yeah, because this is just a very simple thing. So yeah, you just keep adding. And then basically all you do is you hit the trash can. You can either hit the trash can button or Control C. Yeah, there we go. And that gets you out of it. So yeah,
Okay.
that's yeah.
Thank you. Works now. Works
Okay.
perfectly.
Good deal. Okay. Anybody else? Thought I had somebody else. Hey, Maggie's back. Hey, Maggie. Gonna make you a coder at some point. Zoom. It's not Zoom. Don't blame Zoom for Spectrum. I guess I've got to go have a nasty gram with Spectrum. I don't know. Spectrum was working fine. We've been in here 3.5 years. Spectrum was working fine for like 3 and some odd years. And then all of a sudden it started to get a little wonky. And it is. It's about the same time every day, about 3:30, 4 o'clock every day. Seems to do something wonky. Anyways. Chat. Oh yeah, people were saying stuff in chat. Help me maximize this. There's Maggie. Let's see, chat. Oh yeah, okay. So what? Edward. Oh, Edward to everybody. While true. Why do you have stars and stuff? My list equals while true new equals my lists print my lists. Yeah, that looks good. Sure, with Edward. It's fine. It works as expected. Okay. I went through your GitHub repo. Do you plan to edit them like the SQL intro or ChatGPT API? Oh, the old classes. Yeah, so so again, so I've been doing Silicon Dojo now for a while. Uh, I don't know, 2.5 years. And so when I was doing the in-person classes, basically the same thing. Again, there's the product that I'm giving you. So this class is a product, but I think the more important product is actually creating the concept of the classes and creating something that you can take and do something with. So anyways, some of the stuff before was from those old classes. So the Django intro seminar, ChatGPT intro seminar, intro to Linux. So when I did these classes were 2 to 3 hours long. Well, if there were night classes, they were 2 to 3 hours long, and some of them were day classes, so they were 8 hours long. And so basically what I'm going to do is I'm not going to really modify these. I don't plan to retry to do these anytime soon. What I'll be doing is I'll basically be gutting them for their parts. So we are going to have, again, it's not ChatGPT, it's actually OpenAI. So OpenAI API, we are going to have classes on that. And so what I'll do is I'll go and gut the old material, I'll update it with 4.0 since that's the new standard. And then I'll try to figure out how to turn that into like an hour seminar. So we'll do an hour seminar on, again, the ChatGPT API, then we'll do DALL-E, then we'll do Olama, then we'll do other things. So yes, so same type of material. Again, I got to rewrite it though. Welcome to be a technology professional. Redoing the same crap that you already did a little while ago. Like there's this idea like, yes, I finally did this and I will never have to do it again. Until you're rewriting the crap that you did before. Let's see here. Still got 14 participants. Yeah, I've got 7 messages. Lost you, Eli. And yeah, that's what now you're back. Zoom meeting. The stream was going great. Thank you. Try downloading the Adobe classes, but the file was corrupt or it wasn't opening on my end. Downloading the Adobe class? I don't have Adobe classes. You know, the problem with downloading the Adobe classes is I don't have any Adobe classes like at all. So I don't know what you're downloading. Got to the download file from GitHub. What do you mean? So you go to online classes, right? And then whatever it is. So we got the dictionary and loops. All right, let's go here. And let's say we want the PDF. So I can click on that. And should be able to click on download. So again, if you don't want to waste a tree and you got a secondary computer, go ahead and click on the download. All right, it should work. It says it downloaded. Yeah, works for me, as they say. The two quotes that are gonna make you lose your mind as a technology professional is we keep doing it that way because it's legacy and it works for me. I don't know, works for me. Um, let's see. Do you plan to move to a different programming language like Java? I cannot imagine doing Java. Let me count all the reasons why I might teach you Java. Don't got none. Don't got none. We probably will. So next week, So we're going to do reading and writing files on Friday. Next week, probably Tuesday, we're going to do intro to HTML. So that's a language. We're going to do intro to CSS on Thursday, most likely. We will be doing SQL, structured query language. That'll be coming up for databases. JavaScript, probably learning JavaScript, some JavaScript, probably in September-ish timeframe. So other languages that you'll learn, like actual programming, because CSS and HTML, oh God, don't say that they're programming languages. People will lose their damn mind at you. So you will learn those. Those aren't really programming languages. You will learn JavaScript, or we will do classes on JavaScript. Yeah, I don't know. Like if I was gonna teach any language, I mean in 2024, yeah, it would not be Java. Honestly, probably Rust. Probably Rust. Like Rust is, I have a warm feeling about Rust. I feel like Rust is like what the new kids are playing with, but the new kids aren't quite the same assholes that the Node developers were. Like I don't know what it was. Like Ruby developers took, oh, they were just horrible people. Anyways, Ruby developers, they took the arrogance of the tech world just to the next level. And then I felt like the Node developers just like one up those folks. What I gotta say is Rust developers, I mean, knock on fake wood, but Rust developers seem like pretty decent human beings. So we're gonna learn like a new language or whatever. Probably be Rust, to be honest with you. From everything that I've read about, again, I got to play with it more. Yeah, probably Rust. So yeah. Um, George, to everyone. George, are you raising your hand? That's not how we raise our hand. George, that's not how we raise our hand in class. We raise our hand by clicking on the react button and then clicking raise our hand. That is how we raise our hand, George. There's only so much I can do for you people. There are limits. Limits. So yes, just in case, I don't want to be considered a complete asshole. Not a complete one. Just a little bit of one. Oh lordy, where is my damn? Did Zoom? Oh, Zoom died on this. Hold on. Oh no. Um, Open link. Register. Allow. Let me into my own class. There we go. Okay. Do you want to continue with auto? Yes. All right. So basically, to raise your hand, you come down to reactions. You click on reaction and you do raise hand. And that is how we get our hands raised. Yeah, so everybody's clear. Other stuff doesn't work. Let's see here. It is the Windows install PDF that crashes. Wow. There's the answer. You're using Windows. Yeah, I can only do so much. Again, like I think that's the one thing, again, and this is no snark aside, like everything I have in front of me is Macs. Everything I use is Macs. And do you want to know why I use Macs? Is again, to say that it just works it is incorrect. There are problems with Macs. It's not perfect. But it's not Windows. It's not Windows. So yeah, so if you're going to be learning programming, especially the Python classes, Ubuntu is good. Macs are good. Again, I have a last year's MacBook Pro sitting right here. Because they just don't run into the same damn problems. Again, like that's a whole install. So if you go to GitHub, there's an install Python for Windows PDF that I created. And the reason that I had to do that is because Windows is a disaster, right? If you want to install Python onto Mac, it's already installed, but you just upgrade it. You go to python.org, you download it, you install it, done. You want to do it on Ubuntu, you do sudo apt install Python 3 or whatever it is, and it's done. You do it with Windows? Oh God. You go to python.org, you download the installer, you run the installer. But here's the thing, and this is pure Windows. If you install Python 3 with the default configurations into Windows, it does not by default add the environment variables so that you can actually call Python 3. Once you've installed it, it's still a damn rock, and you've got to go in and change environment variables and other horse crap. So literally for Windows, if you're going to install Python 3, you go through the install, and then basically you select all the options, and you go to custom install, you select all those options. Basically, you keep selecting all the options, and then you hit go, because in order to get Python 3 to work properly, you have to do a custom install on Windows. That is Windows for you. So yeah, I mean, again, and like that is going to be one of the problems. Just so everybody here knows, is again, snark aside, I'm going to try to support you people as best as I can. Once we start dealing with things like the AI, especially things like computer vision, once you start dealing with computer vision, computer speech, um, Python is going to need to interact with your hardware directly. And so that's something called device drivers. So you have the hardware on your system, and then you have the device driver. The device driver is what allows the operating system to actually interact with the hardware. And one of the things that I'll tell you is, my God, Windows, it is a damn disaster. Trying to get some of those Python frameworks to work is just what the hell. So I have my robot. If anybody's been following me for any length of time, I have this weird little robot. It runs off a ASUS AS6. It's an AMD processor. Anyways, I bought this computer. It's like a computer about this big. I bought it for about $800. It's awesome. It's like a 4 gigahertz processor. It has all kinds of stuff in it. Anyways, when I got it, it came with like Windows 11 Pro. So I paid for Windows 11 Pro on this little thing. And I was like, I'm a computer professional. I know Mac. I know Ubuntu. I used to be an MCSE. Eli, it's time. Stop being snarky. Just figure out how to use Python on Windows. Yeah, that lasted about a damn day. I sat there for a day because I have my robot, you can talk to the robot. It has AI functionality. It has vision functionality. It's running commands in Arduino. Like literally, oh my God. I spent a day trying to get that damn thing to work using Windows. And at the end of the day, I wiped Windows permanently off of the system and put Ubuntu on there. And in a couple hours, I had the system working properly. So yeah, Windows is Windows. Just you do you. You do you. Just telling you. Sorry, I wrote it wrongly. The intro to SQL, for example, was .pages, which is an Adobe app. No, Pages is not an Adobe app, but yeah. So again, I use Mac, and I don't really want to pay for. Um, I don't want to pay for productivity software unless I have to. So you will see. So if it's .pdf, it's a PDF. It's the extension. If you see .key, that means Keynote. So the slides that I show you is using Keynote. If you see .pages, .pages is Mac pages. So it is. Yeah. Anyways, Mac pages is basically a file format for Mac. So that's what pages is. So that's not actually Adobe. It is oh, it is Apple's document. So if you have Word, if you have Google Docs, if you have Open or LibreOffice or whatever, you should be able to open the dot pages in one of those pieces of word processing software, and it should, you know, it should show up for you. We'll see. Hmm. Yeah, the dot pages will not show up. Yeah, so going through all this stuff. So dot pages, right? So lab book, dot pages. If I click on that, we're just gonna get this. If I actually want this, I download it and I can use it. Dot PDF, I click on dot PDF and that'll actually show up here. Yeah, so for whatever reason, shocking because GitHub is owned by Microsoft, but dot pages does not show up. Works on my machine. Docker, okay, we'll ship your machine. Oh, just Archer. What are we doing, just Archer? Just Archer, what are we doing? Enter my SQL classes dot pages. Yep, that dot pages is a, yeah, dot pages. Got over it. For the EU market, surprisingly, Java is still dominant in the enterprise sector. Well, there you go. I will be the last person to say I understand how the European economy works. As I tell the European folks, it's kind of like you know how you look at our gun laws and our healthcare system, and you have no idea how the crap that functions. That's how I look at your economy. So, and so, yeah, I don't know. You guys might be using Java over there. I don't know. It is an important thing to understand. Again, like when I do these videos, one of the biggest problems with doing content that's globally accessible is it is important to understand that there are geographic quirks. Again, when I got my MCSE, so that's the Microsoft Uber certification 20 some odd years ago, everything east of the Mississippi in the United States, they went with the MCSE. Everything west of the Mississippi in the United States, they went with what was called Novell NetWare. Um, same, different. Basically, they did the same kind of security stuff on a network. Anyways, it was just like this weird geographic thing. Again, PHP. So PHP, huge in the East Coast. Ruby on Rails, huge in the West Coast. Who the hell knows why? Again, there's arguments for PHP and there's arguments for Ruby on Rails, but it wasn't that, right? It wasn't like, oh, we need to optimize our hardware resources, so we're using PHP. And these people are like, oh, we need to optimize for our development environments. We use Ruby. It wasn't that. It was just like if you're in New York, you're using PHP. If you're in San Francisco, you're using Ruby on Rails. Why? Who the hell knows? And so that is something to be thinking about. And this is why it's important. Like a lot of people come to me, or they come to people like me, and they said, Eli, what should I learn? And I'll tell you, I had no idea. You tell me what problem you're trying to solve, and I will point you in a direction. But if you say, what technology do you need to get a job? Again, whether you're in Bangalore or Boston or Bonn, bees, right? It's literally different. It's what the people there are hiring for. And so that's one of the things you really got to be thinking about is a lot of people don't again, it's not about the best language, right? It's not Rust, whether Rust or Java or C# is the best language. It's what people are hiring for. Like when I was in the Baltimore area, I knew a CIO he literally told me any coder who was willing to learn C#, he would give them a job. Like, as long as you knew what the hell a function and a list was or an array was, and you wanted to learn C#, you had a job making like 100 grand a year. And the reason is because we have a lot of big businesses there. We have a lot of government contracts there, right? They are married to the Microsoft stack. C# is the language for the Microsoft stack. And all the cool kids are learning Node and Rust. And the problem is, you have these major organizations that just need people to create pretty crappy apps, to make sure print services function. Um, and so that's the thing. Like if you're in that area, C# might be the best way to go. And so that's why it gets like, and that's why nowadays I try to stay away from talking about what technology or whatever you need to get a job. Because again, in the modern world, it gets really, really wonky. Again, I have a good friend of mine who is just rocking it with COBOL. He's just rocking it with COBOL. It is hilarious. I've been to meetups where I've seen some snots. You know, some of these like 30-year-old node developers. They're always the node developers. And they'll be talking down to my friend. They'll be talking to me like, oh yeah, was it the sunk cost fallacy? And I'll just be laughing. Because I'm like, yeah, he's doing better than you, Bucko. He's gonna be doing better than you for a long damn time. But anyways, right? Yeah, it depends on what people need. Sorry, sir, it was a mistake. Physically raise your hand. Check this. Um, Windows is what is affordable for students, though. Ubuntu is free. Ubuntu is free. Let me show you something. I'm going to show you something. You know what's affordable to students? What's affordable to students are these damn things. These are 2012 MacBook Pros. And you know what's funny? You can actually run Olama on this damn thing. So this is what I bought for Silicon Dojo for our classroom. They cost anywhere between $125 to $150. You can actually swap out the hard drives. They're still slightly repairable, so you can swap out the hard drives. So put solid state drives in here. 4 gigs of RAM, solid state drive, and Ubuntu. You can actually install Ubuntu onto Intel Macs, and they work like a damn champ. So yeah, Ubuntu is free. Ubuntu is free. Again, I get it. I get it. You can't afford a Mac. You can't afford a real Mac. I understand. You can't afford Ubuntu. Can't afford Ubuntu. Yeah, if you don't know about back market is fabulous. Bought a lot of computer again, like I say, for the stuff. I bought a lot of computers off of back market. And yeah, let's see here. If we go to MacBook, and here we scroll down and we say we want the 2000. Why can't I get the 2012 MacBooks? Anyway, anyways, you can buy a 2013 MacBook S. Ooh, those are kind of pricey. Well, I don't know. $254. MacBook 13-inch, 2017. I don't know. You want $254 for that? I don't know what the hell's going on here. Anyway, oh, sorry. 201 fuel. Do they not have any more of those anymore? $2012. Okay, so I click on 2012. We do low to high. And yeah, there you go. So yeah, that's basically what we got here, right? 90% less than new. Well, you're not gonna get that new anywhere. So yeah, so you get a i5 4 gigs, 512 gig hard drive, swap it out with solid state. But yeah, so you get this for 112 bucks. And then you throw Ubuntu onto it. And then you have a real operating system. Sorry. I do like this. One of the reasons I do like these, so these aren't powerful. Again, if you want to do AI stuff, if you want to do computer vision stuff, these probably are not going to be powerful. They can kind of sort of do it, kind of sort of. One of the things I do like about these, for simple stuff, again, with simple OpenCV, is the webcam. When you use Ubuntu and you install Ubuntu onto this thing, everything just works like a champ. All the device drivers work perfectly, including the webcam. One of the weird things I've found, because I've got 2 MacBooks too, I put Ubuntu onto those. Webcam does not work perfectly out of the box. So the 2013 MacBook Pros are actually far superior to the 2012s, but the device drivers for Ubuntu don't work perfectly. So that's where you get into some quirky stuff. But anyways, Ubuntu. Ubuntu. You can afford free. You can afford free. Oh, where are we at? 403. Let's see here. The only thing is that works less than Windows so far. Windows is devolving to that though. Thing with PC is that unless you're PC is Linux certified. You can have a lot of surprises. Yeah, even if it is Windows certified, you can still have a lot of surprises. Again, I don't know. You do you. You do. You might do a dual boot. You might do a dual boot. You know, one partition for Windows, one partition for Ubuntu. I gotta say, Ubuntu works pretty damn well nowadays. I don't know what it is, and even back when I had my computer repair shop. So when we had my computer repair shop, I had one of the guys that I hired was actually he had retired early as like a VP of IT for a major bank. And he loved Linux. He wanted to stop talking about Linux. And again, this is like 16 years ago or something. What was amazing about Linux, even back then, is device drivers. Fucking fabulous. Again, like you would install Windows XP or 2000 or whatever we had at the time, and so many times you had to go hunt and find the device drivers. Just putting device drivers back onto a Windows computer after a wipe and reload could be a complete pain in the ass. The funny part was like DSL. There's something called DSLs, damn small Linux. It's like a 50 meg Linux file, I think it was. Anyways, you could install DSL Linux onto your computer, all the device drivers would work. Anyways. And so my guy would keep giving us crap because we're repairing Windows computers. And I'm like, well, yes, Windows computers might be crap, but that's why I have enough money to pay you. So shut up, find the damn device drivers. Um, let's see. Okay, we'll be wrapping up. Okay. For people who listen to you outside that are outside the United States, Jesus, how valuable can it be when you talk about job opportunity or demand when most of your experience seems to be US? I'd also like to add what I've seen. It's quite hard to land a job in the US while you're outside of the US, or I may be horribly wrong. Open to thoughts. Yeah, again, I know the US. I'm gonna say something that you may not have heard an American ever say before. I don't know, man. I don't know. As I say, whether it's the Japanese or the Indians or the French, and they look at our healthcare system and they scratch their heads, I just want you to understand that's how I look at your economic system. Right? Jobs and the rest of that, again, it's where you're at and what do people in that area need. Again, it's actually it's important here, even in the United States. Like so I'm in Asheville, right? I'm in Asheville, and so I had offices for about 2 years, had people coming in, and it was adorable. It was adorable. I'd have some people like, and they drive in from long distances and they'd be asking about how to move their career ahead. And then like there was this one guy, and I had this nice office, and he looked outside on the one of the city parks or whatever here, and he's like, "Yeah, well maybe I should move to Asheville." And I just started laughing my ass off. Like, no, motherfucker, do not move to Asheville. Guy lived in Charlotte. Charlotte has a metro area of 2.8 million people and truly is one of the major hubs for banking in the entire country. If you live in Charlotte, do not move to Asheville in order to move your career ahead, right? There's just no jobs here. Again, that's one of the I'm curious what's going to happen to Asheville as remote work dies, because it is dying. And as the tech recession and the large recessions start to take hold, is we have so many remote workers here and their jobs are everywhere else. Once those jobs start going away, I think it's gonna get brutal here because we just don't have a lot in tech, right? Again, like I interviewed the CEO of one of our local ISPs, literally, and again, it's on my main channel, so it's there. I'm not saying anything that was told to me behind closed doors. And he had like 18 employees. So this is an internet service provider. They run fiber optic. They're one of the largest fiber optic providers in Western North Carolina, and it expands out all the way up to Virginia or whatever. And he has 18 employees. And I looked at him. I was like, oh wow, so how big are you gonna get? Are you gonna get to 200? Are you gonna get to 1,000? He was like, no, no, no. We might get to like 20. I don't know, 22. I was like, what? And he literally told me, he was like, well, Eli, like I know everybody's name and birthday. I really like running a company where I know everybody's birthday. It's like, fuck. You're an ISP and you're okay with like maxing out at 20 employees. And again, like development shops here. Do we call them development shops? Right? PHP and WordPress. That is, and so yeah, that's the thing. Like if you want to get a job in Asheville, learn WordPress and how to serve beer, because you're gonna need to know that too. But yeah, that's the thing. It's all again how things are in France, how things are in where Tokyo, all those kinds of different places. They are different. So again, I can offer you advice on how to solve problems, how to get a job. Yeah, be very careful about that. And anyways, we are after 4 o'clock. Is it possible to set up a remote career consultation with you? Not yet. Maybe I'll start charging for that. Maybe that's how I'll make money for Silicon Dojo. I don't know. I've done hundreds and hundreds and hundreds. I think when I finally stopped, I've done like 400 to 500 of those. Yeah, just kind of like, I don't know. Doing career consultations is a curious thing because like that's one of the problems. Like people always want, many times people want answers you can't give them. You're like, I do not know your economy. Yes, Eli, but what should I do? I don't know your economy, but what should I do? I don't know, dude. I don't know. So, anyways, we might do consultations in the future. Maybe. Who knows? So, anyways, uh, that's about it. That is about it. So we have the next class. So if you're on Meetup, the next class is going to be Friday. So Friday, 2 o'clock, we're going to be learning about how to read from files. So we're going to actually pull the information in. We're going to parse files and do stuff with it. We're also going to learn how to dynamically write files. So whether you're talking about a text file or an HTML file, I'm actually going to show you how to do that on Friday. And then like I say, next week we'll do HTML and CSS, and we're just going to keep rolling along. So that is all I have for today, because I've actually got to go run to an AI meetup tonight. So yeah, see you guys.